Hello and welcome to Shape the System, where we find and tell the stories that help people to rethink the way the world works. We interview people from all over the world who are helping to change our systems for the better. Shape the System is an independent podcast with support from KPMG High Growth Ventures, who help ambitious founders and their teams scale up for success. More about KPMG High Growth Ventures after the interview. We hope you enjoy this episode.
Hello, welcome back everyone. It's going to be a warm episode today, and I promise I'm not going to do too many heat jokes, but we are going to be talking all about heat. And it's actually come up a few times in the show before. We've had chats previously about energy and how countries and even the globe consumes energy. And one of the things that's always been a glaring omission in these conversations over 100 episodes over 5 years is we've never really talked about heat in an industrial context. And so I'm super excited today to actually get the opportunity to talk to Nis Benn from Hyme Energy about this. So as we firstly do, Nis, welcome to the show, and just give us a little bit of your background of where you're coming from and how you came to be working on this problem. And then we're going to dive straight into the problem space and then go from there.
Thanks, Vince, and thanks for having me on the show here. I've been looking forward to share Hyme's story and my own as well. Well, just to kick in with my own story first, my first startup was back in the end 90s when I was in high school. Started a high school magazine that was advertisement funded. It still lives today, many years after I left by now. So that was built for the long term, apparently. But I think that wasn't really meant as a company. I did found another company for real in the zeros doing statistical analysis, which was my specialization within sociology, which I studied. Sociology was a field that I felt interested in because I really wanted to do something in the world and wanted to understand what was actually the dynamics driving how people interact and how institutions work. So when my first startup was shut down after 4 years, we were about 4 or 5 people trying to grow it all the time, not really succeeding with making it into a product, what we were doing. So it ended up being services only and consulting more than that. So I switched into consulting for real, working in the public sector, trying to shape that sector. Then after 10 years of doing that, I actually joined a political startup for a green party in Denmark, which we didn't have at the time in 2015. I joined to build up the national organization. So actually building out 90 local representations, building a member organization of 11,000 people and getting us ready to do activism and start doing politics in a new way. That wore me out completely, but it was super engaging. And the focal point of that work was on climate and on being problem-centered. So the party was not really built on an ideology. We were a middle party, and then we could sort of collaborate with everybody on the problems that everyone could agree on, which was, depending on your viewpoint, could be climate, it could be poverty. It could also be excessive immigration, whatever that means. So that was a super exciting period, completely different place and way to work than I had been used to, but really engaging with it. I was also completely worn out after 3 years of working in that sector, basically nonstop. So I had a kid, and then coming out of that sort of cage or nice hideout, depending on how you look at it, from day to day, it could be both. I started working with startups in Copenhagen, where the startup scene has been really accelerating for the last 10 years or so, especially within the green space, climate startups, and a lot of them focused within tech. And after working within fashion a bit on Take Back and in a couple of other setups, I met a company in nuclear energy, actually. And working with a new type of small modular reactor, which was a thing that after having looked at it from the political side for 3 years, was seeing we really still have some things that are missing in order to be able to make a political vision that will bring us where we are going. And this was secure baseload at the time that we were lacking. Renewables was working, but what do we do when sun isn't there? Nuclear was the answer for at least a couple of years. And then while we were working on that, I was an external helping the company out. But then I started looking at how can we accelerate this? Nuclear is heavy. What can we do? And with one of the founders of that company, we looked at what we were able to do. And I'll get back to that just a second. And what we saw was we could do this same as nuclear, but in a different way.
Right.
Making energy available always, which was the theme. And then we wanted to see where does that make the biggest difference? Who needs that the most? Who has the biggest problems in turning their current operations into something that's climate sustainable? And we looked at industry, we looked at storage and storing renewable energy to make it 24/7 available for big heat loads. And that's how we ended up in that.
What an arc of a story. Did you say there was a fashion thing in there somewhere as well? I just picked up on that small.
Yeah. I was helping a small company that was helping other companies set up take-back solutions for the fashion products.
For like returns and stuff.
Automate the reselling and add some services onto that. And that's still going today. We're mostly working in shoes.
Yeah, understood. And you said something else that I just wanted to touch on because I think that we're going to have this, not comparison, but we'll use it probably as a jumping off point, at least in some capacity. You just said that nuclear was quite heavy. Did I hear that word correctly? What did you mean by that?
Well, it's a heavy regulatory process, and it's also a heavy design process. And those things, of course, fit together. So developing a new nuclear technology and getting it approved is going to take you anywhere between 10 and 20 years, basically. 10 if you can move really fast, but that's unlikely because you're going to stumble on stuff you haven't really thought about in your design that then you have to reiterate because of something in regulation. So that just takes a long time. So the company also exists, Salt Energy. It's here in Copenhagen. It's right across the street. Still living closely together. They're still innovating in that space and bringing that to market. And part of the core IP is what we spun out into a separate company. Wanted that to be able to build faster and use it for basically the same purpose, but without all the regulatory clutter around it.
Yeah, wonderful. And we'll get to some of how that works later. But let's come back straight up to the context that we're sort of talking about today, which is industrial heating. And I'm going to wrap this up in like 2 or 3 questions, but they're all related, which is what is it actually doing? How is it utilized? And how much of it is happening? And you can use Denmark or Europe as an example, and we can extrapolate from there. Like, let's just get people in the zone, because most people won't even be aware of this as an idea, I don't imagine.
Yeah, so let's just describe the problem a bit, maybe. Industries produce stuff, and a lot of what they produce is produced with heat, because they have to break something up to make it available for refurbish. So you break oil into constituents to make plastic, or you melt something, or you dry something, you bake something. Some of that is low temperature, some of it is super high temperature. So process heat in the industry is really broad, from 60 degrees of Celsius up to plus 2000. And I'm going to be talking from Hyme's perspective about the middle, but the basic issue is the same. All of this is often processes that are running all the time. In big factories where you want to keep them going because your investment is earning you money by the product you make. And today you're burning oil or natural gas or coal to produce that heat. Sometimes you use a bit of electricity, but that's then often made from coal or oil or gas again. So it's the same. It's a microcosm basically of the big transition. We have a lot of processes that here they're just tied to heat.
Yeah. Wait. So it's directly, sorry, just before you jump in, so it's directly burning coal or gas. It's not relying on that to generate electricity that's always on. It's a baseload generation of heat directly. It's bypassing electricity.
A lot of it is, yes. So around 80% of the energy use in the industrial sector is heat, and it's coming from direct incineration. Typically, it's using water evaporation, turning water into steam, and then using that somehow in the process. But in the steelmaking sector, it's direct incineration in a furnace. So there can be those different versions. And the reason we focus on, where we put our focus, is that our technology works in a specific temperature span where steam is the most common heat medium. So we can't go to the super high temperatures in your steel mills or your iron ore melting facilities. We work with steam production for all of the processes that use that. So if any of your customers are looking at uh, fitness powder, this what's it called?
Protein powder.
Yeah, the protein additives that you want to drink when you do fitness, right?
Yeah, protein powder.
Yeah, yeah. So that has a lot of constituents made out of a process that we're working to decarbonize. It's a milk drying process. You basically take milk, dry it up, then you're left with the protein, and that's put into all of these products for fitness, for example. Super intensive process. 13% of all the milk produced in Denmark goes there, and then you dry out the water from it. It just takes a lot of energy to make a protein powder, basically.
Right. I never
That's
realized.
one thing. Nobody ever thought about that. The same goes for distilling your food oil. So your sunflower oil, for example, is distilled at 280 degrees, typically with the use of steam. So all of the things that we surround ourselves with have heat embodied in them somehow, or at least a lot of energy embodied in them. And that's what we want to work with. So basically, what we're doing today is we're looking at taking a medium to store energy. That's number one for us, because we need to move energy from when it's available as electricity to make it available all the time. And the medium we store in is salt, a specific type of salt called molten hydroxides. Hydroxides are a group of salts. One of them is known as drain cleaner. So you would have it in your house. Typically there you have water in it, so it's a fluid there. But if you didn't have water in it, it would be a white powder. And this medium we chose for two reasons. One, because operating with other molten salts, it could have been household salt, has been known from another sector called concentrated solar power. But the salts that we were working with in the nuclear company that I mentioned were just excellent for this exact purpose. They have the highest energy density, basically, of any medium that you could want to store energy in. But they hadn't been used because they're super corrosive, and which is why you use them for drain cleaner normally. But we were trying to use them in nuclear when we needed to bring down that corrosion to negligible levels. Succeeded with that. So what can we use it for now? Let's use it here. So we have a medium that can store a lot of energy, and what we basically do is we use electricity in an electrical heater, heat up this salt so it melts. Then it looks like water, so it goes from white powder into just a transparent fluid. And then we heat it up even more, so up to 520 degrees. We pump that from the heaters into a hot tank where the battery is basically charged when it's kept there. So imagine a 12-meter diameter tank that's 10 meters high, pretty big tank, because we need a lot of energy for these industrial customers. And it's situated right next to the industrial site. And then when we basically pump all the time out of it also, because we're discharging all the time. So we pump the salt back out. We exchange that heat from the salt to water, turn the water into steam, and that steam goes directly to the industrial heat off-taker. And then the salt goes back in a cold tank from where it sits in molten form at the lowest possible temperature before it solidifies. And then we can pump it back as soon as electricity is available, heat it up again. And then it's basically a cold water to hot water, you could say, except we're just operating at higher temperatures.
Yeah, understood. And I want to get into some of that detail. I have some questions about it, but I just want to come back to kind of the impact of doing this, because it's kind of, if we think about the status quo today, if we take heavy industry that relies on industrial heating, now you could take the full spectrum, or you could just take, the Hyme Energy sweet spot in that kind of 200 to 600 Celsius or whatever it is. Like, how much of an energy use of a nation might be this type of manufacturing? Are we talking single-digit percentages, or how big is the problem? Is this that this is all based on coal or natural gas?
If we look at it globally, it's around 30% of all emissions in the world come from industrial heat. So that's pretty massive. It's the single biggest emission sector of them all. If we look at industrial heat as one sector, and then we can split it into all of those subsectors that I mentioned, depending on the temperatures. But that shows us how big a challenge it is, and there's a climate angle to it, but there's also just the cost angle to it. So this is in our niche of the market, it's $1.3 trillion being spent yearly on energy, buying fossil energy to power your process.
Right.
And so that's a huge amount of money. Nobody likes to spend that money, basically. It's just cost that you put into your product, or you want to reduce that. So there's a climate side to it, but there's also an economic side to it, especially when, as we are in Europe, energy prices have really been rising. CO2 taxes have come on top of your energy costs to even drive that more. So for a lot of companies here, there's a financial incentive that's driving this. So could we bring that huge number down to a slightly lower number on our cost of goods sold, basically?
Yeah. And I want to talk about the cost bit as well. I want to wrap that into kind of how this thing all hangs together. And you kind of touched on it. But also coming back to kind of how the world looks today, just to really sort of frame this, right? So there's a huge amount of energy being used. It's being used fairly inefficiently. And probably the same parallel as when you drive an EV, most of the energy in the battery is converted into spinning the wheels and therefore productive output. My guess is similar in your case. If you've got electricity that's heating molten salts and then turning into steam, that's a hell of a lot better than burning coal to create steam. So from an energy usage, energy efficiency perspective, there's an uplift. But then there's probably another kind of more geographic consideration here, which is no one wants heavy industry near where they are in terms of where they live and where they play. But the biggest driver for that must be these things are stinky and ugly and make a bunch of noise and all the rest of these societal impact problems. And does that dynamic change when Hyme Energy sort of steps in?
Well, it could actually change to the degree that, I mean, when people aren't incinerating stuff near you, the air pollution goes down quite a lot. So it could change that a bit. But still, most of these industries have other stuff that could explode or that could spill or any. So they are typically in regulated zones anyway. And then often a city has been built around them in the end. But in Australia, for example, I mean, industries are located in relatively remote areas with two advantages. One is the environmental one, and the other one is the availability of energy now in the solar age that we're entering.
Right.
And
Interesting.
And I mean, we're seeing a different angle to how our solutions work in Australia, because in Australia there is a natural reason to move to solar as it is now, and anyone who's not doing that is not taking rational choices in terms of energy cost.
Yeah.
But when you look at it from the reliability side, there's obviously a huge issue, which I imagine is being discussed in Australian politics also. But for an industrial
Yep.
player, that's what it's about. I want to have my production be reliable and high quality. The energy cost is secondary. So how can I realize lower energy costs but not lose reliability? And then that's where large scale storage like Hyme steps in. In Europe, it's about taking cheap hours in a renewable energy system and optimizing. But there's really an entirely different opportunity in a country like Australia or others in a solar belt around the globe. To
Interesting. So this is kind of going to lead to my next question, which is, it feels to me like there's an emerging and further advanced in some places where there's higher, renewable energy uptake, probably driven by solar because of the availability of sun. That means the conditions to do what you're doing are now becoming really, really relevant and will probably continue to become more relevant. Not just the cost of energy going up, but the availability of cheap renewable energy to make the cost differences lower or even negative. Would that be fair?
Yeah, definitely lower. I think we're looking at still. I mean, storage is super expensive because you're basically building stuff you would ideally not need. But
Right.
in order to move this energy into time, you take an extra investment into your storage and then to optimize your power cost, basically. So you're looking at 6 to 10 year paybacks on a typical storage plant like ours, depending
Right.
on placement and energy market. But when you're past that, then you've sort of locked in your heat price at a much lower level than you previously were at, because then you have
Right.
your solar cost all day round, basically.
Yeah, but if you had to make a comparison of, hey, we already run 3 factories, we're gonna open a 4th factory. Chalk and cheese. If you had the opportunity to build it next to a solar farm and take their offtake, during the middle of the day to power your salt thing, you would never put, no, well, let's go and get a new coal thing. You'd be like, why would you? Is that
Yeah,
fair?
exactly. Yeah,
Yeah.
completely agree. So if you're an industrial customer, you're still thinking about reliability. So you might still build a coal boiler next to it just because in case it failed. But then you wouldn't do that from an energy cost perspective. You would do it from a reliability perspective. But this,
Yeah.
I mean, this is actually kind of the interesting thing being a startup in the space, because this reliability thing is what people don't expect from startups. They
Right.
think, oh, it's innovative, it's new, but does it really work every day, every hour, every minute? And I think that's exactly what we're struggling most with at the stage we're at. We're finishing up our product development and moving into commercial stage over this next year. And getting the risk allocation right with these industrial customers is not easy.
Yeah.
And there's limits to how much risk we can carry in economic terms as a young company. So how do we build our product into theirs without a risk of disturbance to the process that matters most to them, the output of milk powder or whatever else?
Whatever it is they're making. And I was, when you were touching on kind of the process, this, hey, electricity comes in, electricity turns something that's liquid but low temperature into a liquid that's high temperature. That goes into a container that's obviously non-corrosive and stores all the energy, which then talks to the place where steam would otherwise be generated. It just heats it in a different way. A big part of that must be basically not having to retrofit any of the factory. As long as you've got a thing producing heat with steam, you can do that with Hyme as opposed to doing it with whatever you were doing today.
Yeah, exactly. This is a huge advantage of focusing on the medium that they're using, steam, and just producing it another way, because then it's just a pipe put into another pipe, and then you're in the system. So that part of it is relatively easy and helps us to start a lot of dialogues in a place that people understand.
Yeah.
And then what we're trying to innovate on as one thing is how much can we make it not the industrial customer's business? Can we work with financial investors to own those assets, and then just have heat offtake agreements where you just agree on some heat coming out, and then the industrial customer is basically off the hook in terms of investments or operation of the system.
So wait. I want to make sure I understand that point. Sorry to cut across you, but so someone today is buying coal to produce heat, and they have to do the economic worry about what's going to happen to the price of coal, what happens when the coal generator happens. And your thought process here is, don't just deliver them with a new bit of kit that creates a new worry. Find asset managers who essentially will say, I'll just sell you steam or I'll sell you heat. You need 220 degrees all the time, 24 hours a day, 99.8% of the time. I'll sell you that outcome. You don't even have to worry about the rest of it. And this is what the price will be.
Yes.
Oh, that's fascinating.
So,
sorry, I just have to mull on that for a little bit. That's really good.
Yeah, me too. We weren't in that place a year ago, but it's come to the forefront that this could be a deployment vehicle and a contracting setup where we could sort of help the right interests work together. The company taking off steam, wanting to lock in an energy price, financial investors wanting to deploy capital into green transition, and Hyme wanting to develop these systems without too much friction, basically, on the sales cycle.
Yeah. Well, and also I think, like, sorry, you go.
Please. No, yeah, too.
Yeah, I was just going to say, like, you change. There's two things that happen with that, which are quite interesting. One is that you enable a decision to be made on a balance sheet. So if you might be a relatively small player in the tech space, you've got a GE out here who's capped at $400 billion or whatever their market cap is. But as a company, you aren't a good balance sheet decision. And I've been in enterprise software enough to know often that is how a decision gets made at an enterprise. Even if they've got an inferior solution that costs more, they're like, well, you don't get fired for recommending IBM or whatever that kind of trope is. But if you shift it to the technology is how an asset manager who already has $200 billion worth of assets deployed, and they've been managing them, they've got a very extensive track record. And for them, they're like, well, we're able to take that risk and we're able to understand that risk and arbitrage and manage that risk. And then suddenly the balance sheet is their balance sheet, not yours. So that's the kind of the first interesting thing for me. And then the second thing that's interesting for me is if Hyme spent all of its time focused on building the capability and innovating around the capability and the delivery, and maybe even to a degree the operation or supporting others to operate it, then you would get incredibly good at that, and you could leave the capital and sales and deployment of these assets into the broader world to a whole bunch of other people, which would allow the scale to happen a hell of a lot faster too.
And that's the last thing there is basically my motivation to. So I'm trying to really get into the mindset of those potential partners at the moment, and being way too much of a CFO in how I think, but that's because those companies you're talking about are financial companies. They're just thinking about assets as financial assets that they manage, refinance, sell, whatever they do with them. And that's just a machine of capital deployment. And I'm trying to sort of bridge that gap right now. So getting a bit about what we're actually doing and see what if can I get into this from a cycle that basically just eat projects one after the other, and then do sort of licensing agreements instead with those organizations on our tech platform. And that's moving forward, but it's still, I mean, there's of course still a risk discussion between us and those financing companies. But it's actually sort of simpler to discuss because it's all about money in that case.
Yeah, I think, well, the thing that's, there's almost a beautiful irony here that if highly variable costed renewable energy ultimately created a new business model for energy security and confidence in terms of certainty, in terms of the heat context, like that dichotomy is just lovely to to imagine. I want to get back into the engineering in a sec, but I do want to ask one question just about conditions, because I kind of touched on it. In Australia, there's a whole bunch of solar and highly renewable energy pricing, which supports, hey, maybe we could get heat in a different way. Is there any other trends that are happening or emerging that are kind of the tailwind for what you're doing and why now, and why this is really going to come into its own in the next 5 or 10 years?
So I think we should split Europe away from the rest of the world in this case,
Sure.
because Europe is its own regulatory environment. So if you just take Australia, I would say, or another solar country, I would say most likely not. It's an economic optimization.
It's just price of solar, yeah.
And that, but that's also what makes things nicely simple. If you can show that business case, and you don't need politicians to meddle in it in a positive or negative way, then that's really just perfect.
Sure.
And there is some support in Australia, for example, from the government for the first pilot project in this. But I mean, when we post 2030, it should really be something that runs by itself. In Europe, it's a bit more difficult because our renewable energy system is less predictable, which means that it's hard to calculate the same low daily price that you can then move to the rest of the night. Because in Denmark, the sun just isn't there in the winter, at least not in a meaningful sense. And then the wind doesn't really blow in the same predictable fashion. So the way you optimize your plant is completely different. So what drives it there is not the price of renewable energy. It's the price of the current alternative, natural gas.
Right. Interesting.
And that's being stacked up by the CO2 taxation scheme that we have. And then some countries are adding things on top of that, in Denmark, for example. And that is has been the main driver. Now in Europe, we're sort of in an energy security discussion also. And I have a bit of a hard time actually knowing how it fits in. Politicians talk a lot about it, but I struggle to find out how to valorize it actually in my dialogues. It's not that companies don't understand what happens if we don't have natural gas because of a war situation or something like that. Well, that's a big problem, but what can we really do about it? And they also don't know how to valorize it. So we're sort of, at least at the political level, people are talking about this being a driver, but I'm not really seeing it. So I'm still stuck with the price setting on the natural gas being the driver in Europe, and then the cheap price outside of Europe of solar.
Understood. And from your go-to-market perspective, is that kind of, just as a follow-on question, is that impacting where you're looking and kind of where you're having the most amount of traction, for want of a better word?
Yes, it is. I mean, we are focusing almost exclusively on Europe for our first commercial projects, and then sort of staying aware of and taking initial discussions in other countries. We want to build our reputation based on European projects, and then we want to move with the sort of business model that you were also indicating, where we license to partners to have a replicable, scalable business model. And as soon as we have 3 projects that are well delivered in Europe, since we're building on something that has been partly known before and upgrading that with our tech, we believe we can get there relatively fast.
Yeah. Okay. And let's come back to the engineering, because I mean, you touched on, you kind of put it into 3 boxes. If we had a whiteboard, it would be 3 boxes, and one of them's electricity, one's kind of the thermal stuff, and then one's the the water coming out the other side. Is it as simple as that? Like, what's happening from an engineering perspective? Like, if as comfortable as you are to go into some of how you're doing it, like, now tell me a little bit more.
So our research has been into 3 things that interact in order to create or not create corrosion. So I think most people will know that oxygen, for example, can be a corrosive factor on iron, and we all know rust. And that's basically what we're looking at in our system, how to minimize rust. And we do that in a combination of 3 things. One is selecting, actually 4, but I'll stick to 3. Looking at the salt, and then regulating 3 things: the materials that it touches, the temperatures that we operate at, and the atmosphere that surrounds it. And our research has sort of been in optimizing that space for lowest cost of materials and longest lifetime at the same time, to enable a predictable operation with no breakdowns due to corrosion, but also there's a 20, 25-year lifetime for all the main parts of the system, which we need to have in order to sort of warrant a big infrastructure project as it is. It's not something you can just build and then throw it away and then build another one in place. So the engineering on that, and where our IP sits, is in that triangle of knowledge, basically. So a lot of extensive testing of materials, temperatures, and atmosphere control. And then in the end, we've found a way to control the atmosphere with certain materials, certain temperature spans, that delivers on the promise of long lifetimes and low cost materials.
Got it. Okay. And if I was to ask, like, what are those materials and what are those types of things, is that getting into like the special sauce? I would presume that's really where the magic happens.
Yeah. Well, so one thing that we really wanted to achieve with our experimental campaigns was to show that for the vast majority of the system, we could use the cheapest stainless steel possible.
Right. And 316 or whatever it is.
304, I think.
Okay.
They are roughly the same ballpark. And we succeeded with showing that this year in March. So that was really great for us. And then we have a few parts of the system where we operate with a small coating on top of cheap materials. But being able to build the majority in completely standard steels was what we wanted to get to, because then we can drive the advantages in cost and density that we want to. So that was really a big technical milestone for us to basically end our material screenings campaign and show with long-term exposure that we have corrosion that we can hardly measure.
Yeah, and only because I want the clarity of like thinking about it visually. When you talk about the atmospheric pressure, what you're referring to is inside of the container, there's a molten part, and then there's a bit that's not the molten part. And so it's how much pressure is that, because that impacts how corrosive the thing is inside of the container. Is that what's going on there?
Yeah, it's actually the constituents of that atmosphere that we're working with and manipulating.
What's in the atmosphere?
Yeah, so our if you look at our patent portfolio, you will see a method to regulate this atmosphere and its constituents, a sensor to see if it's being done right, and then a system patent integrating all of this. So we had to invent the sensor after we invented the method, and then we can operate it dynamically.
I love it. So you came up with it. We can do this as long as we can measure it. Can anyone measure it? No. Okay, we'll go and invent that first. Hey, just in terms of process, because I mean, I think about like I've spent 20 years building software, and there's a process for building software, and it's through computers because the nature of what you're doing is on computers. But then when I started to do a physical product, I found that there was kind of this, you had to kind of work in both universes where there was heavy use of computers to design things and even understand how things might operate and work together, and also physically, aesthetically, how they might look in my case, because it's a fashion related product. But then you had to get out of the lab. You had to get into the real world and have 7 different prototypes and try different tolerances and different ways of putting them together. Like, as you've approached this challenge, how much of this is being done in the math CADs and in the kind of sensing software or using AI or whatever, and how much of it is, we've got to build another one of these things that's, Dyson vacuum cleaner number 441. Like, how's that process work for you guys?
It's regrettably physical, not because I don't like that, but because it's of course slower and more costly to do.
Sure.
What we've done is we've invented new methods to basically do corrosion testing at massive scale in labs, because people in universities were used to doing one sample at a time, and then merging that for 40 hours looking at it, and then putting a new one waiting 100 hours. So we've invented methods to do a lot of things simultaneously with a lot of samples, and so we could probably sell that as a new method to corrosion testing for other companies, if we needed to. But so we will try to accelerate that, and with process innovation in labs, basically. And then we have sort of different steps of scale-ups that we've built and operated alongside. So every time we had a new result that sort of limited our space of operation in the right direction, we started up a larger campaign then with 100 liters of salt instead of 10 milliliters in a small crucible in the lab. And then we have built an industrial scale demonstrator on top of that as our proof of concept and full technical readiness proof. We're just upgrading that after it operated for the first time last year. We just changed the salt content to a better mix, which was the fourth thing that we're manipulating, is the mix of specific hydroxides. So we're not only using one, but several. And then we're recommissioning it, and then it should be done, the demonstration side, for us sometime next year.
And like skill set wise, like I'm thinking about a company actually based in WA that's working out how to build plastics using seaweed. I haven't spoken to them. They're coming on the show later in the year. But when you go and look at their kind of list of, the about team, that page on the website, like the types of people who have to be involved in that, most of them are kind of molecular biologists and all this. Is it your parallel is people who are like all, chemistry and chemical engineers? Like what's the types of people who have to understand how the stuff might work?
Yeah, so it's a really good question. So actually we start out by being a chemistry company. And so that's just so far away from how we talk about ourselves, because nobody really needs to know. But that's really where we're coming from, with a 8-person team working with traditional methods and then innovating on top of that to gain speed and more clarity, more statistical security in what we were doing. And we continue with that for the next 3-4 years, I think, at the same level. And then we can start to step it down as we sort of emerge from everything and can just work based on learnings from commercial plants.
Yeah, I mean, like I was, I'm kind of reminded of what's going on a little bit in, the move from kind of, ICE vehicles to EVs, and you've had I think someone I spoke to yesterday it's coming there, episode's coming out in a couple of weeks, but they were talking about how we've had 100 years of refining the performance we can get from a petrol engine, but we've really only had about 20 years of refining what we can get from batteries. In some respects, there's a better than fair chance that you're on a similar arc where there's still a lot of opportunity to refine the materials and how they interact together and what they're coated in and their mix and the pressure and probably 2 or 3 other things that you haven't even thought of yet that will continue to change this dynamic, I would have thought.
Yeah. And I think our team there, they would like to move into developing new metals. I mean, because now we found out what these metals don't exist. This would be an ideal one, because now we know all the ones that weren't ideal, and if so, we might move into that as well. And if we are going to be a massive success, we might as well make our own metals and source that through a partner.
Sure.
Get a new recipe. That's where their dream goes.
You'll have to rebrand to alchemy.
Yeah, exactly.
That's
And
super good.
you
That's
can
actually a
find
good segue.
you're
Sorry.
spinning gold one way or the other.
Yeah, exactly. It does. It leads me to a question that's not specifically about going into other business lines, but a lot of what you talk about, or one of the three things you talk about on the Hyme Energy page, is this idea that if you install Hyme as a industrial heat required, manufacturer, you actually end up with these other revenue generation opportunities. I want to understand that a bit more.
So what you have to think about is that the electricity consumption side of the plant is operating in an energy market that is being continually optimized by energy traders. And those energy traders are reacting to market signals of under and overproduction, basically at the minute level almost, and sometimes even second level. And then they are also operating in a grid stability market where they are helping TSOs, transmission system operators, and distribution system operators to stabilize the energy system at the same time. And you have one advantage from having a large ability to consume. You can buy when energy is cheap. That's one thing, and that's what the base operation is: buy cheap, sell at a higher price. That's the arbitrage you also mentioned. But then, as soon as that is up and running for you, whether you postpone that purchase of energy for 5 minutes or an hour, that allows you to play in what's called the intraday market or intra-hour market and help other people out, basically, who are maybe suddenly short of power or suddenly have a surplus that they hadn't forecasted. So forecast errors are something that plays a heavy role in price setting in the smaller markets, which gives you an upside because you can turn it down a bit. And since you have 16 hours in your tank most of the time, then you can also just wait 2 hours to charge, even though you had planned to, and give that to someone else who's willing to pay more in that hour. But you bought it first, so you're selling it to them. So that's one. And then the grid stability services are very, very country and region specific. But this is where the transition system operator can pay you to say, oh, there's a big forecaster at system level. We need somebody to shut down their charge. Can you do that for, let's say, $200 per megawatt in this hour? Yes, we can. We were only planning to earn 30, so 200 sounds nice. And then you play up an optimization game in several markets at the same time.
Yeah, and so I understand it from a commercial perspective. It's basically arbitraging, the variable price of wholesale energy. But from a pure kind of process capability perspective, so is Hyme a closed loop where it can also turn the stored molten thing back into electricity? Is that what's happening there, or?
No, it's not. It's just a change in how much we use, basically. So if we were planning to use 30 megawatt in an hour,
Got it.
if we don't use that, but only use 25, that corresponds to producing 5. So
Right.
the grid doesn't know whether it was new production or whether it was somebody who just turned down their consumption.
Interesting.
So
So,
that has the same effect.
yeah, that's really interesting. So, because the existing paradigm of large energy usage is that someone says, "I'm going to need this much energy every single day, day in, day out,"
Yeah.
they have essentially created an arbitrage, a forward contract for themselves that they can then not take because they
Yes.
don't need it in that particular moment, and it has the same impact as supplying that same energy to the grid in that same moment.
Yeah, you can say that.
That's a fascinating
Yeah.
arbitrage. I never even thought
Yeah,
that would be possible.
Yeah, it is actually sort of weird to get into that thinking. So when I buy the energy the day ahead or the week ahead, then because I have a storage plant, then I'm super flexible on the day, and I can just say, no, I don't need it anyway. You can buy it. I'll buy it later from someone else
Yeah.
who then has a surplus and who can sell it to me cheap at that point in time. So energy traders will be a big part of operating our plants. We did have a long discussion with ourselves whether we should sort of go into that, but that's been taken over by a lot of good companies, and it's increasingly AI dominated as well. So model and algorithm based, meaning that the margins are going to be small on that. So we can
Very
find
specialized.
with energy traders who are really good at doing this. So we decided to stick with the physical system and the automation of that to keep low operating costs, and then have others do the energy trading.
Yeah, understood. And so, from where you guys stand today, you said you've got, a pilot plant or a plant of some sort coming online in Europe. Your objective is to have three in Europe. I think it's much to have kind of the brand association with this must be legitimate, must be good because they're running it in Europe. I think there's certainly kind of a cachet that comes with coming from Europe. You guys have got good brand over there, Denmark specifically as well, but even more broadly at Europe. Like where to from, like in the immediate term, where to kind of in the medium term, kind of the next 1 to 2 years, and like what are the big challenges and roadblocks, or mountains to be climbed from your perspective to get where you're trying to get to in the next 1 or 2 years?
Yeah, so our goal is to have our first final investment contract into a plant by the end of 2026. That's when we've set up ourselves to be ready for it in terms of engineering systems, planning systems, quality control, supply chain, working to get all that in place and lined up. So that's goal number one: is a first plant starting to basically
Coming out of the ground. Yep.
dig end of 26.
Yep.
And then we want to have basically increase the amount of investment decisions by one the next year, so we don't have too many parallel projects as we're still learning a bit. But then to really start scaling as we get towards the end of this decade. So from 2030 onwards, we should be doing 7-10 projects a year around then, and then scaling further. There's thousands and thousands of these sites, and I think we are working to get 1 to 2% of that market, and that will still make Hyme a very, very big business with sales in the hundreds of plants. So, so what might sound as small numbers in some sectors is really big numbers here, because each one is like $30 million.
Yeah, no, I definitely get it. I'm in a space in Australia where I operate, where doing half a dozen a day feels like is a good number, and for most people, like, I only do half a dozen sales a day. I'm like, that's actually quite a reasonable number to do because of the value side. So I totally get it. And then in terms of the enablers for that, like one of those enablers is the client and the willingness and getting through a sales process. There's obviously a capital element of that as well. Is there a regulatory element? You talk right up front about not being as heavy as nuclear, but there must still be hey, someone has to sign off that this thing's okay and we can put one of these things somewhere. How does that look?
Yeah, well, we haven't found any blockers yet. So we've been looking at 2 sites very in depth here in Denmark, 3 if we include our demonstrator site, and then we've been looking at sites in Spain, Portugal, Germany as well. And so far, we haven't applied for final approval, but we also haven't, through our dialogues with authorities, heard anything that would be a blocker on this. And the reason is that what we're storing is hot and it's corrosive, but that's been done in a lot of sectors. So sodium hydroxide is being used as an ingredient, for example, in a lot of foods to regulate taste. In very small amounts, but it's being stored on site. It's typically not hot, but it has the same corrosive effect if it ends up in the wrong place. So a lot of permitting around this is solved either in a corrosive materials sort of regulation, or in what do you do with things that are really hot and melted regulation. So it doesn't seem like we're going to hit any barriers there, which I'm pretty happy about, of course. We do have one advantage over other salts that we're competing with that are trying to work with the same sort of design setup, that we don't have any noxious gases coming out of our system, and most of the others do. So that sort of eliminates the daily operation side of it. So it's only the catastrophe scenarios that sort of need to be screened.
Yeah, understood. And it sounds like when you kind of looked at this from inside the nuclear, and obviously with your policy understanding and lens on the other side prior as well, part of what made this a magical kind of, hey, we should take a really good look at this, is understanding that this would have a much, much, much lower policy barrier, meaning that the curve to adoption would be much easier as well, both the pace of and the level of effort involved.
Yeah, that's definitely part of the matrix we were trying to build when taking the decision was on this, and then saying, we know we can do this thing with no real barriers, only normal barriers for a startup in terms of finding product market and getting things done.
And all the other barriers.
Yeah, but we know we can do it. So whether the nuclear business ever gets to market or not, we can start working on this problem. And then if the nuclear sector comes out and suddenly becomes super profitable and very cheap and can outcompete everyone else, then but we'll be happy about that. Then we had fun in the meantime, and it made a meaningful difference. Yeah. And if it doesn't come and solve it, then we've been a major piece in bridging from strong renewable production to baseload green energy.
Yeah, and for a thing that represents almost 1 in 3 of the energy units that we consume globally, of which 70-80% of it is being driven by fossil fuel sources, like the opportunity to be part of something so magical in any capacity. And if the worst comes to the worst, then someone invents fusion and takes all of this away from everyone. I mean, you guys can go off and produce amazing new corrosive resistant metals.
Then I'll go to the lab myself and have fun there.
Exactly. That's wonderful. Awesome. We'll leave it there today. I think you've covered a beautiful arc of a story. It's really exciting. And I love hearing about these things, both from a process and a policy perspective, but from the actual engineering perspective as well. Like, it's going to be super exciting to see, and I can't wait to sort of check back in with you guys and see how you're traveling in the next year or so. But thank you so much for being on the show today, and hope it all goes really well for you.
Thanks for having us, Vince. It was really fun, and thanks for your curious mindset. It helped me to learn a few things as well as I was speaking today. So thanks a lot.
We hope you enjoyed this episode of Shape the System. As usual, if you'd like to suggest a guest, someone that you know who's helped change a system for the better, please go to www.shapethesystem.org, click on the top right-hand corner, then click Suggest Guest. Make sure that you click subscribe so that you get the new episode. Shape the System is an independent podcast with support from KPMG High Growth Ventures. Connects founders to the services they need along their journey. Whether you are looking to refine your strategy, mature your finance function, prepare for a capital raise, expand abroad, or simply comply with regulatory requirements, they provide you with the support you need to drive your business forward.